Welcome to the channel where all you gotta do is make some control arms for this V10 Mustang. So this is a fixture that I made 12, 13, 15, I don't know, many years ago. It's for the lower control arms for the Sonda, my crappy lemon race car. So I dug it out of the wine cellar, and these are actually bars to make a spare, which we've never needed, amazingly enough. And this is like a threaded in replacement bushing for a Chrysler control arm. You can buy, I guess the flat tracker guys or the late model stock cars or something, they use the Chrysler ball joints because they're pretty stout and they thread in, so they sell them with this little sleeve. So anyway, that's what I'm utilizing here. Available, and they're available in a bunch of different offsets. So I shouldn't need, and they're fairly high articulation, which I shouldn't really need. But so anyway, I have this fixture. It's just a good place to start. This happens to be at 17.5 degrees. From there to there, I only need 5 on the Fastang project. And I don't want to really ruin this thing, but I'm going to utilize it by, making it this half. So basically I'll do the same thing. I'll cut some 1.5 inch stock. The width that it needs to be, which I think in this case is like 2¼ inches for these types of bushings. And then that just slides inside there. I'll use less rusty stuff, but anyway, it goes in there, trust me. So I'll cut this to the right length as a spacer and then just sandwich that together. And then I'll put a mount for this guy. This is for the upper control arm. The lower needs a different setup, but that's fine. I'll make a new this thing. So I'll need to put it on a 5-degree angle. And I'll probably make it, because there's a left and a right, and they're not symmetrical. It's not a symmetric triangle, so it's shifted a little bit, a couple inches. So I'll probably put a thingy at 5 degrees and make it so you can make one control arm like this and another one like this. So I don't have to make 16 fixtures. And for the lower control arms, I'll probably do the exact opposite and make it hold the pivoting part on this end. That one's a couple inches longer. And then this part will be on this side, so they won't interfere with each other. So anyway, I will start getting some control arms cut and some of these guys cut, square them up on the lathe, make my spacer bar. Yeah, so we'll get some soon. Maybe not real soon, but soon we'll get some tires hanging off of that. Okay, so I'm fixing to get ready to do something here, making some lower control arms and whatnot. But this is the ball joint I'm planning on using here. Goes in like that. Trust me, it fits. Doesn't look like it, but you articulate it, you can slide it in there. But this is what came on it. It's kind of squarish. It's just an angle. And this is what used to be in there, which had this little roundy thing on there. So I just took my puller, pulled that guy off of there. So that sits into this little counterboard here. Super nice. So basically what I got to do is make that fit on there. And then this diameter here is 18 millimeters. And this is 16.5. So I'm going to stick this on my cheesy little lathe and turn this guy to the proper diameter. So I'm just going to put this in the 3-jaw chuck and put the live center on that. 45-degree chamfer there. And that should center it just fine. I may need to put a drive dog on here just because the friction in here and here may not be enough, but it's pretty tight, so I think it'll be fine. And then, yeah, I'll just machine that to 16.55. I'll press that on there, and then that'll be my lower ball joint. And I just want to add this to, you know, people doing crazy stuff like I do. The way ball joints are made is they machine the socket in the male part, and then they make a center doodad here. Sometimes there's a little plastic thingy, a little plastic insert like that, but basically the inside looks like that. And then they just jam it together, slide it in. This is from a different part, but slide it in, and then you can see this part here is just formed. So they spin it and like roll it in there and sandwiches it all together. Kind of how spark plugs are made as well, but the key point I'm trying to make here is make sure you load it the direction that it needs to be loaded, right? Because if you try to make this so the weight of the car is trying to pull this out of here, it's gonna unswedge that and be a problem. And some of them, they have like a cap on the bottom that's swedged, and some of them have a cap on the top that's swedged. So sometimes there's a hole here, and they slide this stick. Quit rolling away. Listen to me. There. Sometimes there's a hole here, and then they slide this whole mess inside through there, without the nut and whatever, and then they swedge that side. So make sure, and you can't look in a catalog and it says whether this is a pushy innie or a pulley outie. You just have to look at the, you know, vehicle suspension geometry and look at the spring and figure out whether it's in compression or it's in tension. So this one is in compression, so that should be fine because it's going to go like that. So, and then the control arm will have the spring on it, so it'll be pushing this down, and then that pushes this down, and then wheels pushing back up. So that'll be fine. So anyway, I want to get all this stuff done before I make this control arms. I just ordered the bushings for the control arms just to make sure that they're a plasticky part, so it may not be perfect, but so I have to make this part as well because this used to be a McPherson strut car, and McPherson struts are shit. So McPherson struts are not the most optimal design for suspension geometry. There we go. So got this hunk of metal. I picked it up at the local metal recycling yard, $2 a pound or whatever. So now I got to machine that, and there will be a ball joint. So this is the upper ball joint. It's kind of a K727, I think, like a Chrysler. They make lots and lots of variants of these for dirt track racing because they're super bulletproof, and they even have ones with bigger pins, and they lengthen these and whatever. But and then they come with this little, or you can buy them with this little spacer, so you can just weld your control arms to that. This one's been sitting around a while, and that'll just go right in like that. And then the nut goes in like that, and then the nut goes on the back under there. Still get to it and roll on that way. So anyway, I want to get all this stuff, you know, kind of ready. I want to get this piece made up so it can go into there, and I can get this all. It's all cartooned up in CAD, so I'll just make a little cartoon drawing and bring it out here. And then this one also needs kind of similar to this piece here, but you can't buy them, of course. I'll have to whittle that up out of a hunk of metal. That goes down in here. And then when I do make the control arm, I can throw it on there and put the fender on and make sure the wheel is, you know, precisely where I want it, and it rotates right, and my Ackerman's good and all that stuff. So it should be, it's all in CAD, but you know, sometimes the real world isn't exactly the same as what's in CAD, especially when I'm doing the CAD. Okay, so I got these guys machined up. Well, it was harder than Superman's kneecaps for part of the way, so I had to grind it. But I got 2 of them. I also turned the OD here down to 2 1/4. I might even turn it down a little more, but just so I don't have to, you know, clearance that even more. So, and then I got another one of these guys ordered. It turns out this is a 772, not a 727. 727 is like a super burly one, which is the one I'm using on the Bronco, like this guy. And the difference between this and this is a pound. This weighs 2 pounds, but without this ring on there, this weighs 1 pound. So you can see it's, one of them is large and in charge, which you kind of need for the Bronco with 33s on it, and pounding around out in dirt, smashing into the rocks and stuff. But this guy, yeah, this will have nice smooth forces on it, unless I do something stupid, which of course I won't. Okay, so those guys are done, and they did fit in here, but they didn't really have much room to articulate. So basically, just this had like a really sharp corner, kind of like that up here. So I just kind of rounded it off and polished it, kind of got the stress concentrations out of there, and now this just slides in. And you see it from this side. So the control arm, the diameter that's going to sit around this thing, 2 1/4 diameter pipe, only goes up to the snap ring. So that should have plenty of clearance. Doesn't articulate much. This thing's only got like 4 inches of travel, so it should be fine. Now I'll run down to the wine cellar, get the left side version of this, and do the same porting on it. And then I'll get to making this guy. Okay, so I dug this one out of the wine cellar. There's all the giblets I took off it. Control arms, 30-pound rotor. But you can see that this is all really sharp because this is a forging. You can tell it's a forging by, see this parting line here is really wide. It's like 3 millimeters wide. If it was a casting, it would be a really small parting line. And what they do is they forge it, but they don't forge this hole in there. They just forge it solid, and then they go through and they punch it to, and it's like a trimming die. It trims all the edge of the forging. So that's why there's this wide parting line, because that's still there during the forging, and then they put it in a little fixture and it trims all the way around. But anyway, that's why this is sharp, right? And that's not good. Sharp edges are bad even if they're on the outside. They're worse if they're on the inside. But so I'm going to do the same thing to this guy that I did to this guy. While I'm at it, I might go through and, you know, touch some little imperfections and stuff. But I'm going to throw this in my solvent tank, get it cleaned up first so I don't get, you know, icky hands. And then maybe I'll throw this on the float bench and see what it flows. Okay, got these guys all cleaned up. These fit in there nice now. No problemo. So I just need to get the tubing for that pipe, I guess. And then this, gonna get some holes drilled in it and the taper. So that slides in like that. And then the ball joint will be sticking into that guy, the nut will be on the bottom, and then this gets clamped. And then if I want to change my camber curve, I can just move this up and down by putting a spacer in between this little, that little notch right there. I can move this up, I guess, or down. So I'm also thinking about putting like a bolt hole in here, so it can't slide out that way. It can't go that way because it has a stop, but it could migrate that way. I don't know why it would, but normally this thing has the McPherson strut spring pushing it down, so it's never going to pop out that way. And now there's a potential for this thing to move out, and it's only held by friction, so I may put a bolt in there to make it a positive stop. So anyway, it's what you got to do when you're taking parts that are made for something else and make them work for what you're doing. Okay, so I got some more of this stuff whittled up. This is this one had a little bit of, didn't quite clean up there. It's right on the low of the tolerance, and it just barely cleaned up. So I use that as my setup part. So I make one, slides in like that, and I still have to put the ball joint taper in there. Okay, so there it is. It's gonna be fun to get the cotter pin in there, but I think I can manage. And the upper control arm tubes will weld to that guy. And then this slides in. Ta-da! Okay, so I took this old fixture that was made for suspension arms for the Sonda, and I stuck it on the milling machine. I drilled some holes in it and tapped them. So the way this works is this piece here was the original piece from the Sonda, and it slides into the sleeve from a Mopar 772 ball joint. It's got like a threaded sleeve. So this was an old one actually. It had these two in stock. And these are 2 3/8 OD, but you can't buy those anymore apparently. The new ones are 2 1/4. So I know the unsprung weight is important and stuff, but so is the wheel not falling off. And these seem like it's not going to muck up the threads as bad when I weld to it. So I think I'm going to use these thick ones. But anyway, you can buy a tap to fix up the threads, but it's $450 or something. I don't think I want to do that. So anyway, so this goes here and gets bolted down, and then a 1/2 inch dowel gets in these 2 holes here, and I'm going to put a piece of 1 inch 1x2 bar. So these things will sit like 1 inch away from that, from tangent to here to where that bar is. And then that is the correct length for where this needs to be. And as you can see, this thing is stepped up a little bit. So when this is, well, this needs to have a spacer under it as well. So it goes like that. And when the pipe is welded from here to here, that gives this thing the 5-degree angle that it needs. I'll put something in CAD. Oh, yeah, wherever. So anyway, and then for the that's for the inside holes. So upper control arm uses this hole and this hole because there's a lefty and a righty. And then the outside holes, this is tangent to this edge here. So I'll put that piece of material on the edge here, and then these things sit there, tangent, and then the pipes go in between. And again, this thing is stepped up a little bit. So that's my plan. Need to cut some pipe, some 1-inch, 1/8" wall DOM bar, and yeah, we'll get to slicing and notching and tacking. Okay, so I got this fixture whittled up. Got some dowel pin holes, 1/2" dowel holes reamed. I just put a gauge pin in there. Just put a piece of 1x2 to hold that in the right spot. I just got these guys propping that up, kind of hold it in place. And then part of my fixture is at this point, at this radius, it needs to have an inch parallel in there, so I got an inch parallel. That gives it the 5 degrees. And in theory, if you look straight down there, this pipe and this pipe intersect at that point at about a 3/8 inch diameter. So, which is a little bit hard to do because they don't extend all the way into this hole. So I think what I'm going to do is utilize my new 3D printer. It's under there somewhere. And I'm just going to make a little fixture. Not going to use it to weld this end, but this end. So I'll just pilot off of that diameter there, and then a little saddle for this and a little saddle for this. This guy is centered on here, between here and here, so it's that distance from the edge of here to the edge of that, within a little bit. Just so you know, these things are extra long. This piece here is extra long, so once it's all welded together, and there's a little brace that goes in here. It's actually 2.5 inches from center line to that, center line to that. Once that's all welded in there, then I'll fixture it up and I'll machine these relative to everything perpendicular and the center of this. So I don't have to get this perfectly straight, just as long as the shock fits through there. And then when I'm done, I will indicate this. I'll indicate this straight, pick up this 0, and then take an end mill and slice that to the exact numbers it needs to be. So that way they'll be spot on. Left and right will be well, mirror images of each other. But anyway, so I'm gonna go cartoon up this little fixture here, and we'll get that printed up on my fancy new 3D printer. And yeah, hopefully we'll have a wheel articulating in here soon. Okay, so I got this 3D printed kind of fixture thingy bolted on there. So that locates it. For the opposite one, they have these other holes. Well, the outside holes are for rear, and the 2 holes are for front, for boop boop. So I'll have to make another one of these for the mirror of it. It takes about an hour to print, so that's no big deal. But yeah, this looks really nice. The angles line up really nice, and it's lined up with the center of that, the center of that. So I think what I'm going to do is tack this guy on here and here, and then I've already cut this thing, but it's not really the length yet. But this goes in here. So we'll get that fitted, and then we'll start sparking this thing together. And then once this thing's spark welded together, I think I can put this fixture back on the mill and pick up this 0 here and just run a hole saw through this 2 3/8 hole saw. Or if I decide to use the littler ones, 2 1/4. So that goes like that. And then in theory, I could use this fixture to hold that in place as well. But once it's notched, it's going to stay where it's supposed to be anyway. And yeah, so this is looking good. It looks a little bigger in real life than it does on my confuser screen, which is exactly the opposite from when I worked at that injector company, where everything looked bigger on my screen, and then when you saw it in real life, it's like, ooh, that's tiny. Okay, a little bit more progress here. So I did some arithmetic and figured out it needs to be 1.25 inches between there and there. So I notched that guy. It's ready to tack. And then I clamped it to the table so it can't spring anywhere while I'm tacking it together. Okay, so this might look like MacGyver's been here, but I don't disagree. I should probably drill some holes so I can just use strap clamps to hold this all down, but I think this will work since I have to do so many configurations. I don't really know exactly where I put the strap clamps, but usually when you cheese out and do it like this, it ends up costing you a bite in the butt. So we'll see. That makes for entertainment. But anyway, I got this little guy on here, and it's all clamped down and lined up straight. This bar did tweak a tiny bit when I tacked it, so I just clamped it to the table and bent it. Since it's only tacked, those will just move around a little bit until it's happy. So this is nice and sturdy in here. So what I'm going to do is drill it with 2 3/8, which is the size of that sleeve, and then leave it all on the fixture like this, bring it back to the welding table, and that little countersink there, that should line up the sleeve, and then I'll tack that in, and then I'll pop it out of the fixture and weld everything nice. Okay, so got that 2-0, damn close, and yeah, MacGyver clamps, and then I just went through there with my hole saw, and this little ditch here should hold that at the right Z height. So now I can bring that over to my welding table and tack weld it on and pop it out of the fixture, and then weld her up. Okay, so I got this tacked together. Upper control arm kind of sort of in place. Kind of looks like it's meant to go there. I think this is all the factory whatever stuff. Not sure why that's like that. Probably had to clear the original lower or upper control arm. Anyway, this looks kind of okay. I got my cheesy adapter in there. I got it held up with a jack stand because there's no lower control arm, but essentially that's where it's going to live. Okay, this is the lower control arm. Different fixture. Lower right. And pretty much the same situation. I'll clamp this all down, tack it. I'll put this, still got to cut this, but put this brace piece in. This one's 4 inches from the center line. And tack that in, and then I'll take it over to the mill and make this. Actually, this one's a little bit different size. Okay, so I got my piece of DOM tubing. It's 1 3/4 ID and 2 1/4 OD. So unfortunately I got it a few hours before I'm leaving for Italy. So I can't really do anything with it because I gotta leave, but I did measure it, and this is really close to 1 3/4. And this is like 10 thousandths bigger than that, 'cause it's a metric size. So I'll be able to, what I'm going to do is cut it to the length, and then, you know, hole saw this, weld it in, and then once it's all welded in, then I'll machine the ID of this. So that's going to be really hard to do a mock-up because this needs a press fit. So not sure how I'm going to make that work, but I'll figure something out while I'm in Italy. So anyway, I'm going to end this video here. Lots of cool stuff coming up with the shifter for the SMG transmission and getting this on, wheels on. Got some more work done on this guy, which is like the underneath cross brace to make up for what I removed. So yeah, anyway, I'm gonna go spend a few weeks in Italy with my lovely wife, and by the time you see that video, I'll be back. So like nothing happened, but I will have a lot of video footage to edit and post on my channel. So we can start looking forward to that, I think. So anyway, yeah, don't forget to subscribe and like and share while in my on my vacation. You can always go to my old, there's 150 something videos in there. There's even old stuff from 10-15 years ago on Sonda races, and so there's a lot of cool stuff in there to look at. But I will be enjoying myself. I hope you do the same. Yeah, and I'm gonna steal something from Brian. Be good humans. Ciao.